Thank you very much. It's a great honor to be here. Thank you to the organizers for inviting me. I'm Professor Peter from University of Texas at Austin, and I'm joined on stage here by two very inspiring people who work in a similar area to me. Pindar van Armen is an artist and a roboticist who builds robots that create art, robot artists. And Marita Chang is a roboticist, robotics and entrepreneur who builds robots that help people in need. And so both of them are going to talk about their research and their work that they do. I'm first going to introduce the session about artificial intelligence and robotics. So there's a lot of excitement today about AI and robotics, and it's for good reason. But if you believe what's in the news and in the movies, there's really two main storylines. Either artificial intelligence is going to save the world, it's going to make everything better, create a utopia, or at the other extreme, that it's going to destroy the world, that we should be afraid of artificial intelligence. So the excitement is warranted, but compared to these storylines, the reality is quite different. So the reason that I've been invited to be here with you, I think one of the main reasons, is that I participated on a study panel that examined, with colleagues of mine in artificial intelligence, examined what are the likely impacts of AI technologies in the year 2030. This was the first study panel report in a 100-year study on artificial intelligence. And the charge we were given was to identify the possible advances in artificial intelligence over the next 15 years and their potential influences on daily life, and to specify what are the scientific and engineering efforts we need to make to realize these positive potentials. We also spent time thinking about how can we maximize the chances that artificial intelligence technologies will be put to good use for societal good, that won't be either the dystopian extreme or the utopian extreme. And so there's both technological things we needed to consider and also policy and legal issues. All of these are covered in the AI 100 report, where we focus in large urban regions, a typical North American or really first world city, such as Seoul, looking at the various aspects of artificial intelligence within these urban centers and how they all come together. So the 100-year study was just launched. There's a standing committee. I was invited as the first study panel chair, and we put our report out in 2015, about a year ago. Well, actually, it came out in 2016. And the first thing I would just encourage you, if you're interested in the future of artificial intelligence, to go look up this report and see what we had to say. There's another one being prepared for a few years from now in 2020, and the objective is for this to happen every 5 years for at least the next 100 years, to look at the realistic impacts of artificial intelligence, not the science fiction, but what's really happening on the ground, and that's a little bit what's going to be the focus of our panel today. In this study panel report, we looked at several different areas that are relevant to large urban centers. The ones in blue here are ones that we're actually going to touch on among the three of us in our talks. In the study panel report, we look at the similarities and differences among these various aspects. So I encourage you to, I'm not going to go into more detail about the report itself. Instead, I'm going to transition to the kinds of things that I do and then turn it over to my colleagues on stage to say what they do. But if there are three main takeaways from our report, the first one is that artificial intelligence is not magic. And in fact, just yesterday, I went to the Dongdaemun History Museum just down the road, and was very interested to see that about 100 years ago, when the city walls of Seoul were starting to be taken down, one of the reasons was to make room for tracks for electric cars. People didn't understand why or how these cars would move, these electric cars. And so one of the names that was used for them in Korean, I understand, was devil cars. that these were mysterious, magical cars. People were scared of them. Now, I imagine today, most of you don't understand the details of how an automobile works, but yet you don't think twice about driving in it. You trust that it's not magic, that there are people who understand how it works. And that's similar for artificial intelligence. When something's new, it's very natural to be afraid of it, but it's not magic. There's computer algorithms behind everything you see in the news that people are presenting as very impressive and very amazing. They are impressive and amazing, but they're not magic. We understand as a population, as a group of scientists, we understand how they work. Another important message from the study panel is that artificial intelligence is not one thing. It's a collection of different technologies. So in each of these different areas that you see on the screen, you need to build specific systems that will impact each of them. You can't take the AlphaGo program that beat Lee Sedol in the very famous match last year and use it to make autonomous cars or healthcare robots. Every AI technology is different. And so these are some of the big lessons from the report, which I encourage you to read if you want to learn more. So now, as you hear, I'm going to turn to my own research, and as you hear, the three of us, talking about what we do, keep in mind both our ambitious goal, what's possible today, and also that what we're talking about is not magic, there's specific technologies behind it, and that AI is not done yet, that it's a work in progress. So just briefly, my research goal is to try to create robust autonomous agents in the real world. And this is what I've been working on for the last 20 or 25 years of my career, trying to create autonomous agents. These could be robots or these could be software programs, but that can exist without a person remote controlling them, that can over a long period of time. And so how would we go about doing this? At the beginning of the field of artificial intelligence, about 60 years ago, there was only one way to do it. It was to break down intelligence into various subcomponents, into language, into vision, into motion, into planning, and to have different people working on each of them and trying to put them together in the end. But nowadays, we can take the opposite approach. Instead of working from the bottom up, we can work from the top down, trying to build complete agents to work on increasingly complex tasks. And by a complete agent, I mean one that senses its environment, decides what actions to take, actually executes those actions in a closed loop without a human involved. So in my research, I've used several different domains to study and to figure out how can we build these robust, fully autonomous agents. And I don't have time to go into all the details in this short talk, but just to show you some examples, we've been participating in robot soccer competitions for the past 20 years. These are some robots, the Sony Aibo robots, scoring a goal fully autonomously. This was more than 10 years ago. The robots are sensing, deciding, and acting. This is part of an international effort to create robot soccer agents. And in fact, I was at the first robot soccer competition here in South Korea in 1996 in Daejeon. And these competitions have continued within an organization known as RoboCup, the Robot Soccer World Cup as well. When Sony stopped making those Aibo robots, we moved to these humanoid robots. So here's one of our robots. The ones with the hands behind the back are my robots at the University of Texas. This is in the finals of the competition in 2012. And again, you have to remember, they're fully autonomous. There's nobody with a remote control. They're sensing the environment, deciding what to do, and acting. Here you'll see one of our robots going in on a breakaway against the other team in the finals. And it's going to come up, and this was in the first goal in a game against a team from the University of Bremen in Germany that we ended up winning 4-2. So here you'll see the robot coming up to the ball and banking it off the goalpost and into the goal. We also have a project at my university known as the Building-Wide Intelligence Project. So these are robots here that you can see just wandering through the hallways. If you come to my lab, you don't have to ask me for a demo. The robot's always wandering through the hallways, fully autonomously. And in this research that I'm showing here, it's with a colleague of mine, Ray Mooney, who's a natural language processing expert. And the robot's learning to improve its understanding of human language by engaging in dialogues with people. And so this is also, but the goal of this project is to have robots that can become a part of the social fabric of the building. to be able to interact with people, to help them when they need help, to ignore them when they want to be ignored, to entertain them when they want to be entertained. There's a lot of research challenges towards making this possible, a lot of possibilities that will be opened up, but still a lot that needs to be done to make it possible. And just to give one more example, you've all heard about autonomous cars. Here's a clip from the DARPA Urban Challenge in 2007. Our robot is, let me try that one more time. Our robot's the one in back here that's just having to drive up to an intersection, look for a gap in traffic, and turn left through across the intersection. The cars on the inside were driven by human drivers, and our car was able to sense where they were, decide when it was safe to turn, and then take the action and actually move through this process. It made 8 loops through this track in about 20 minutes. As you know, all the car companies are now building autonomous cars. They're trying to make this a reality. So I don't have this autonomous car in my lab anymore. I'm trusting the industry to make this happen. But we still think about what the world will look like when all the cars on the road are autonomous. Will we still need traffic signals and stop signs? Or can we do something that looks more like this? So this is what I think intersections will look like once we have autonomous cars on the road. What we have here is the cars that are in white have called ahead and asked for a reservation for when they should go through the intersection. So when they're yellow, they don't have a reservation yet, but as soon as they turn white, they have a guaranteed path through the intersection that won't collide with any of the other cars. So we put this video out back 15 years ago, back in 2003, when people looked at us like we were crazy when we said someday there'll be autonomous cars on the road. Now this is becoming much closer to reality, and I think we'll be able to see systems like this. Now, this is with all the cars being autonomous. Of course, when we have people driving cars or pedestrians and bicyclists, we'll have to modify the system, and we've done research on that as well. But there's amazing possibilities that are opened up by this technology.